Welcome back to the Senseable Stockholm Lab Day event. It's time for our next two project presentations, where sensors are being used to monitor the urban environmental conditions in Stockholm. Simone and Mora, please come to me and enter the stage. Start presenting when you're ready.
Hi everyone, it's a pleasure to be here and to present the Stockholm Sensing Platform. So in this project, we look at new ways to capture information about the different microclimates that coexist within the city. And we want to build precise real-time maps of temperature, humidity, but also phenomena like air quality, noise, and heat. And we want to understand how we can use this information to create better and healthier cities, for example, to drive the design of new public spaces or to inform policymaking. But capturing environmental data, it's a hard challenge because those phenomena, they're called hyperlocal, so they change very quickly in time and space. I'll give you an example. Studies have shown that in New York City, within the same city block, air quality can be 10 times worse in certain areas next to other ones. And the ways cities usually capture this information is with ground stations. So those instruments are very good at providing data within their proximity, but on the other side, they're very expensive, so we cannot have we can just have a few in the city. And sometimes the location of those sensors are chosen in a very specific way. So I'll tell you a funny story. In 2009, the mayor of Madrid was running for re-election. And he claimed that during his administration, air quality in Madrid had been better than ever before. Later that year, he was sanctioned by a Spanish court because he had quietly moved the air quality sensor from busy streets to parks and gardens. So in this project, we asked ourselves the question, can we use mobile sensor to complement the ground stations in order to achieve a higher resolution both in time and space? And even better, can we deploy those sensors on vehicles that they go already everywhere in the city, like buses or taxis? So can we turn those sensors in environmental platforms? And to answer this question, we had to face two challenges. The first challenge was to understand how many vehicles and how many sensors we need to cover the city. How many do you think we need? So according with our studies, where we looked at taxis as sensor within several cities across the globe, we found that using only 30 taxis, we can cover almost half of the city at least once a day. So not bad. And the second question that we faced was, can we create a platform that is so easy to deploy that it doesn't disrupt those vehicles' everyday operation, like moving people or transporting goods? And to answer this question, we got our hands dirty, literally. So a couple of years ago, we partnered with the garbage collection company in Cambridge, near Boston. And if you think about it, garbage trucks are excellent sensors because they go everywhere in the city, at least once a week. And we created a device called City Scanner that captures air quality, noise, energy leaks from building. And we deployed those scanners on 5 vehicles for about a year. And the data we collected was then released to citizens in Cambridge that were able to literally to zoom in on a map and check air quality outside their doorstep. And the platform that we had created at that time was very fragile. It required frequent maintenance, for example, to change batteries. So for Stockholm, for this project, we created a new version of the platform that is completely autonomous and is solar powered. It attaches to vehicles with magnets, so it's very easy to install or to move the sensing device from a vehicle to another one. And it captures air quality as well as gas, heat, noise, and temperature and humidity. And after building a fleet of these devices in Cambridge and testing in the MIT campus, we brought the platform to Stockholm, and we launched a pilot study where we used the bus number 72 that runs along a trafficked route in central Stockholm. And by doing this, we wanted to both validate this technology in the Swedish context, but we wanted to start a conversation with you, with the city, to understand how we can use this platform to serve the city needs. So now it's time, this technology is ready, and it's time to put it at your service. And to do so, in the next presentation by Ulla and Sanjana, they will tell you how we're going to use this platform to tackle on a new and probably unexpected problem in Stockholm. So, thank you, everyone.
Thank you, Simone. Ulla, Mörtberg, and Sanjana, please. We're ready for the next presentation.
Okay, great. Thank you so much, Lukas. Hey, everyone. Thank you for coming. I'm Sanjana.
I'm Ulla.
And we're going to tell you a little bit more about one of our projects, Stockholm Heat. If it will, go to the next slide. So why do we care about heat? It's only early October and it's already quite chilly, so wouldn't a little bit more heat be nice? Well, maybe a little bit, but extreme urban heat can be very dangerous to human health. Heat waves are increasing in number and intensity all over the world, including in polar and far north regions. As the planet warms, extreme heat events might become more common, necessitating a better understanding of these events and how to mitigate their effects. So we are interested in researching heat in Stockholm, specifically how greenery and green spaces affect urban heat, outdoor temperatures across the city on a local scale. Urban areas overall tend to be a bit warmer than their rural counterparts due to various human activities, but even within a city, the amount of excess heat can vary wildly in different spaces and depends on a multitude of factors. So we know that urban forests and green spaces help with some of the health risks from heat. Trees provide shade, they prevent sunlight from reaching concrete and asphalt and other man-made surfaces that absorb more heat than natural materials, and they also undergo a process called transpiration, where they release water vapor into the air, lowering the temperature a bit. While we do know that green spaces help, we're interested in understanding these effects better on a much more local scale. To do this, we are using a new version of the city scanner device that Simone introduced that we built and tested earlier this year. We built upon the previous prototypes that we deployed with new functionalities like gas sensing and a customized thermal sensor module. The thermal sensor measures infrared radiation bouncing off of surfaces and allows us to better understand both surface and air temperature. This is important because it gives us a better sense of what places actually feel like and whether surfaces like buildings and streets and other objects are warming or cooling them. So we partnered with Bized Pod Taxis for our initial pilot and worked with them to deploy 5 city scanner devices, which are currently zooming throughout the city, collecting data on temperature, humidity, air quality, and gases. You can actually see in this figure on the right some of the initial data that we've collected so far. The blue dots are indicating areas with lower temperature, and the orange ones slightly higher. So now I'm going to hand it to Ulla to speak a little bit more about urban characteristics.
Thank you. So the urban greenery is an important element of the city, and it needs to be planned and managed, not at least for the well-being of its citizens. And we look at it on very different scales, from the hyperlocal street trees, parks, and urban forests in the urban landscape. And it's a privilege in this project to be able to use big data, big environmental data. So we use heat measurements from the city scanner and combine it with the local weather and climate data. We use Google Street View images for greenery combined with Stockholm City 3 database and the biotope map for the whole municipality with a lot of important ecological information. And for the urban canyon, we use for topography, we use the Stockholm City 3D model combined with Google Street View images for sky view. And we compare all this data. What affects the urban heat on all the different scales? And we want to learn how to improve the city green and gray for its citizens. Thanks.
All right. Thanks, Ulla. So while our initial deployment is still in progress, we're actively monitoring the amount and types of data that we're collecting. So each of these devices is currently picking up tens of thousands of data points every few days, each of them unique. As we wrap up this first deployment, we're already starting to think about next steps, like further investigating factors in urban greenery, such as tree species and health, building upon some of the other projects in our lab. We're also interested in extending our citizen engagement efforts with new visual interfaces to help us better communicate patterns that we find in the data. One of the main outcomes of the project is community engagement and decision-making support. We really want to be able to equip the citizens of Stockholm with the knowledge that we gather from this research through resources and workshops, and support decision-making efforts around mitigation of urban heat strategies through our findings. Thank you so much for listening, and we're very excited to speak with you further.
Thank you very much, Sanjana and Ulla. I will ask two of my colleagues, Peter Wiborn from the Environmental Department and Anders Broberg, to join us in the panel. So, Simone, I will start with a question for you. What are the benefits for a city like Stockholm to deploy a fleet of moving vehicles or moving sensors like this?
Oh, thank you, Lukas. Great question. So I think the main benefit is that we will have this hyperlocal information that I mentioned in my presentation. So we will have these maps showing how those different microclimate, as well as air pollution, noise, and heat, will change throughout the city. And I think this can be used for example, of course, to detect hotspots, to detect trends, but also to drive the deployment of a ground station. So since we can only afford a few of them, then we can locate them in areas of interest, in areas that are most interesting. And the second point, I think which is the more exciting one, is how can we start this conversation with the city and how to understand how we can use this platform for a better city. And again, this is a platform, so it's supposed to be a tool, and it's supposed to be extended in directions that we need to understand, and we will be able only to understand those with interaction with the city and their citizens.
So it would be a good complement to the existing measurements tools that we have.
Exactly.
Yeah.
So it will work in pair with ground station, but also with satellite images.
Yes.
And we use both data, for example, for calibration of our sensor and also in the analysis process.
And if we're about to launch such a moving platform, what kind of a fleet should we purchase or ask for?
Well, I think
They're good.
they're great vehicles because first they're electrical vehicles, so we don't want to to pollute the environment by deploying the platform that is meant to counteract the effect of pollution. At the same time, I think buses, so those type of vehicles, they provide a constant stream of data along certain routes. So we have several data points. We can sort of look at patterns and trends. At the same time, taxis, they go in places, as well as garbage trucks, they go in places where buses usually they don't reach. So I think it's a mix of both fleets. But again, because the platform is so easy to deploy, we can change the fleet sort of on demand.
It's a magnetic attachment to the
yeah,
roof.
It's beautiful design. Actually, Tom contributed. It's a team effort.
Yeah.
So
maybe if for you people in the room, maybe there would be a possibility to look at them outside
exactly.
after the meeting. Yeah.
Yes.
All right. So Peter, what can you see? What kind of use would you see for this kind of the data and the knowledge collected in a project like this?
I think Simone already mentioned it, that the mobility of it, so it can be combined with the different measurements that we already do, satellite imagery and more stable stations for monitoring this. And thus enable us to have this on-demand service also and monitoring. We could put emphasis on different areas in the city where, for instance, green structures are implemented for various amount of reasons, mainly climate change adaptation. So I would say that this adds knowledge also on the micro level, on a very detailed level, where most of the greenery can play an important role for climate adaptation, actually, in terms of heat waves. So.
Yeah. I know also that you in the environmental department, as of today, you calculate all the data for the streets.
Mm-hmm.
So it will be a very interesting task just to compare the data. Although the sensors are not the same, it would be interesting. I have one more question to you before we go on to the Stockholm Heat Project, and that is what the knowledge or the lessons learned from Sensing Platform. Sensing Platform project was finished off, and now we are starting up the Stockholm Heat Project. Are there any lessons?
I think it's so first it's nice to have this transition between two projects. You really show that sort of the results of a research project are useful for another one. And I think, so we've learned a lot from the design and the engineering of this device, especially when we took the platform outside our lab. So everything always works fine when you're in a lab. Then when you start, you go to the booth, you put the device on the vehicles, and then they lose a piece, they lose the magnet. So
they didn't have it was not a metallic roof.
Exactly.
Idea of
So we had to change the mechanism. So we had to design a new binding system for those vehicles because they're made of fiberglass. So in general, we learned a lot on the engineering part, on the technology, how to make the device more reliable. For example, the device is solar powered. And we know that, unfortunately, we don't get much sun here in the winter. So we have basically to work with those challenges, developing also some mathematical model, also some machine learning model to basically predict and manage the system in a way that can operate without supervision.
Anders, what do you say? You were also part in the initial phase. Is there any knowledge from our side or lessons learned?
Lessons learned. Well, it's really great to testing this type of things in a real city, and a city where you have a relation to, so you more can better understand what you can get of this. So then you have a lot of challenge from proving that you get the good data to change your behavior as a decision maker. It's a huge journey, and also not really. You don't really know what is cost effective. Is it really how much we need of this type of data comparing what we're doing today or other sources and things like this? So it's a long journey or learning lessons in this.
And that's good. That's what we are here for, to learn, right?
But I also say it's when you see this, you can start discussion like this, and it's more real, and you take next step with this type of real testing.
Okay, so Stockholm Heat, Ulla and Sanjana, what new information do you think that this project will give us on heat in the city?
Well, from the greenery side, it's really interesting to combine this completely different data set and look at what scale is it important, and do nature-based solutions really work? We can really have a look. So it's really exciting for me.
Yeah, absolutely. I think that one of the huge benefits of this project is just providing information to take more targeted interventions with respect to urban heat mitigation and kind of try and identify what are the hotspots, what are the priority areas, so that when undergoing the long process of climate change adaptation, we can kind of do so in a way that keeps the city comfortable for everyone who lives in it.
Yeah, and put our investments in the right places.
Exactly.
Right? Mm-hmm. That's very good. And why is it, when you work on heat mitigation, and why is it important then to measure, as we do in this project, both the temperature in the air and also the radiant heat?
Yeah, no, that's a great question. It's essentially because it gives us a better sense of what it actually feels like to walk around in spaces, to be a human and experience what the heat stress is like, as opposed to just pulling out your phone and checking the weather and then going outside and finding it's 3 degrees warmer than you thought it actually was. So this gives us just more information on kind of what people are going to be experiencing as they walk literally from block to block, which is a much higher resolution than we had before.
Yeah. I know also that in this project we are looking at the micro scale, but you, Peter, you have been involved in other projects that are on the regional scale, more or less, with SMI. Is there a possibility for us to share or to exchange, you think? I mean, you will do it, of course, but also for the project.
Yeah, I hope so. We are actually trying to find out the maximum temperature over 10 years, so in Stockholm at the moment. But using satellite imaginary or images is a limited scale or a higher scale of this. So these two combined, since knowledge is quite high that the greenery that is very effective in reducing local heat must be super local. Mm-hmm. So probably we could identify the hotspots in the city quite well with satellites, but then we need to go into more detail with this measurements.
On demand, as you said.
Yeah,
Okay, our time is up, but thank you very much for the discussion. It was nice. Anders, you will start. Follow up. Thank you.